Tomorrow's Wednesday. Is there a quiz tomorrow? Yes or no? No. Told you no already. Those of you that are paying attention. All right. I'm going to review with you tomorrow because your test is Thursday. All right. So review tomorrow, test on Thursday. All right. So the last lesson of this factoring chapter for us is factoring completely. Factoring completely. Now here's the thing. There are a lot of different possibilities. And we have to be able to understand some principles so we can care for all the possibilities. I can't show you every possibility. We don't have time. But I can teach you the principles that should help you with the different possibilities. And that's what we've got to learn today. So, first off, we're going to deal with things that are fourth degree or higher. Fourth degree or higher. All right, let me get my shade out here. All right, so our first example here is 7x to the fifth minus 7xy to the fourth. Now look, we know to do what? Factor out common factors first, yes? That's what we got to do. So if you look at this, somebody tell me what common factors to factor out. Ethan? 7x. The only thing common to both terms is a 7x. That is correct. When you take a 7x out of the front, what is left? Now, you all need to be thinking because some of you have trouble with this. Kaylin?
Find the x to the fourth minus.
No, that's all I want was the front. Right, so the front is x to the fourth. When you take a 7x out of the back, what is left? That one should be easy. What's left? Y to the fourth. And again, folks, now is not the time not to think. You got to be thinking every step of the way. Now look, let me help you with some analyzing. Some of you guys are naturally better at analyzing things than others. It's just the way God made you. You're more, I think it's right-brained than left-brained. Thinking right, left-brained than right-brained, left-brained. Huh?
You're 30 left-brained right now.
If you're artistic, you're what side? Right side, yeah, left-brained. Those of you that are really good at analyzing things, you're normally more dominant left-brained. Those of you that are more artistic, artsy, music, that kind of stuff, you're usually dominant right-brained. All right, but just because you're right-brained and you're more artsy and stuff doesn't mean that you can't be able to analyze some things. So, let me help you with analyzing where you go from here. You have to look at this and you have to determine, how do I now try to factor this? And here's one key. If it's only two terms, the only way to further factor two terms is if it's possibly a, what kind? What's the only kind we can do if it's two terms? A difference of two squares. So, if only two terms, it must be a difference of two squares if you're going to be able to factor it. And it may not be that. It may not be that. And if it's not that, you can't do anything else. But that's the only possibility. Do we factor differences of two squares by trial and error? Yes or no? No. We factor them by the pattern I taught you yesterday. So this is going to be factored by the pattern. All right, so remember, don't forget what's out in front. Now let's factor the difference of two squares. First thing, two parentheses. By the way, I was working with somebody yesterday, two people actually, and neither one of them went in this order. Now, and I told them this, look, you can have a different order, but your order better be the same every time, because if not, you're not wiring your brain. Now, I listed down, right, yesterday, an order to have. Factor out common factors first, make two parentheses, plus in the middle of one, minus in the middle of the other, square root of the first, square root of the last. Boom. Every time I factor a difference in two squares, that's what I think. Every time. Every single time, that's what I think. Now, if you think one thing one time and another thing another time, you are not wiring your brain. You're not. And if you don't wire your brain, you're not going to remember it as well. Period. End of story. So you got to get a pattern, and you got to stick that pattern. You got to do that pattern every time so you can wire your brain. So every time I do a difference two squares, I do it exactly that way. Two parentheses, right? We factored out common factors. Two parentheses. Plus in the middle of one, minus in the middle of the other. Square root of the first goes first. Hey, Austin, what's the square root of x to the fourth? It is x squared. So x squared goes in the front both times. Let me go a little higher for you guys. And square root of the back. Now, again, we're looking at the blue part, right? This is where we're at right now. And what is the square root, Lauren Mitchell? What's the square root of y to the fourth? Y squared. So that goes in the back. Okay? Oh, now look what we have. Now we have two binomials. We went from one binomial to two binomials. And now we have to look at each binomial that's left. Is the front one a difference of two squares? What's wrong with the front one? It's got a plus instead of a minus. It's a sum of two squares. And we got to wait until Algebra 2 to factor that one. It involves imaginary numbers. Ooh. But for right now, we don't touch those. Is the second one a difference of two squares? Oh yes, we can factor this, can't we? So we're not done. All right, so grab your blue. So we still have 7x. We still have the parentheses x squared plus y squared, correct? And now we're going to factor the box. Do you concur? Look, it's two things. It's either a difference of two squares or nothing. The first two things was nothing. It's not a difference of two squares. The second is. How do you factor a difference of two squares? Again, every time my brain, two parentheses, plus in the middle of one, minus in the middle of the other. Square root of the front in the front. Square root of the back in the back. Now we have three binomials. Are any of the binomials a difference of two squares? The answer is no, so we're done. And so we're done. So did anybody get 36? All right, so you kept going. Very similar to this problem right here. Right, makes sense? Hey, to completely factor, let me give you the analogy in numbers, guys. Just look up at the screen. You know, if I had the number 24, I could say this is a 4 times 6, but have I completely factored? No. I could go on to say it's a 2 times 2 times 6, but have I completely factored? And the answer is no. I got to finish till everything is to prime or is unfactorable. And that's the same analogy with the binomials and trinomials. Make sense? Okay. All right, so let's go on to the next one. And again, all I'm trying to do is show you some of the possibilities because they're endless. Okay, so you look at this and you say, oh, it's a trinomial. I got to factor out common factors first. Yes? We. Are there any common factors? And the answer is, oh, come on. The answer is no. All right. France, if we went we, it will be no. All right, so the answer is no. There are no common factors, but you looked, right? You looked. You thought, okay, hey, if it's three terms and it is factorable, if it's not prime, we have to be what methodology? Trial and error. And this is what your brain has to say. Trial and error. That's what your brain needs to say. So now you go into trial and error mode, right? Because it's a trinomial. Trial and error mode, two parentheses. Let me use a little color here. I'm going to go black. Remember, the fronts must multiply to x to the fourth. There are two possibilities, isn't there? I could go x cubed times x, or I could go x squared times x squared. What gives you a clue in which one to pick? Anybody know? Remember, factoring by trial and error, it's all about the middle. Which one does the middle indicate? X cubed x or x squared x squared? X squared x squared. See, it's all about the middle. Because the middle is an x squared. So we're going to try x squared, x squared. And notice I said the word try, because it is trial and error. But again, if we think, we'll slow down. Andrew, question?
It's called trail.
Trail. No spelling Kool-Aid for you. All right. Little dyslexic there, or bad speller. I often said if I had to take a spelling class in college, it would have ruined my GPA. All right, and it would have. All right, and so then remember, our backs have to multiply to a positive 4. Hey, but guys, if the middle is a negative, we know we got to use negative times a negative, right? Because they have to multiply to positive. So we got two choices. We got -1 times -4, and we got -2 times -2. Those are our two choices there. And again, it's all about the middle. So look, in my brain, I'm thinking, hey, if I put a 4 there, I already got 4 negatives, and therefore then the other inners gives me the fifth negative, and that's it, right? So x squared minus 1 times x squared minus 4. And that does give us the correct middle. Agreed? Are we done? Hey, we got to keep looking to see if there's more factoring yet. So remember, now we have binomials. If a binomial factors beyond common factors, the only possibility is if it's a, the only way binomials factor apart from taking out common factors is if it's a, look, if you're not thinking this, what did we just do? Back up here. Back up at number 1, we said if once you get out common factors, if it's a binomial, the only way it's going to factor is if it's a, so we're back to that again, right? We're back there again. This is a binomial. The only way the binomial is going to factor is if it's a difference of two squares. Is the first parentheses a difference of two squares? Yes or no? Yes. The front is a perfect square. There's a minus in the middle, and then the 1 is a perfect square. Is the second binomial a difference of two squares? Yes. Front is a perfect square, minus in the middle, and the back number is a perfect square. We have 2 differences of two squares. We got to factor them both. Front one, how do I factor every difference 2 squares? 2 parentheses. Plus in the middle of one, minus in the middle of the other. Why do you have to look? Don't you know how to factor a difference 2 squares yet? Square root of the first. Square root of the last. Right? There's our first binomial. Now we got to do our second. All right, you finish it off as I do it. Go ahead and finish it off as I do it. Shouldn't have to look. All right, so hopefully you did 2 parentheses, plus in the middle of one, minus in the middle of the other, square root of the first, square root of the last, right? Voila. And what's left? No differences in 2 squares, because you need it. You need at least something squared. The front is an x to the first power. That's it. You're done. Everything is x to the first power. You're done. It's got to be at least an x squared to be a difference of 2 squared. X to the 4th can be a difference of 2 squared. X to the 6th can be a difference of 2 squares. Can an x to the 5th be a difference of 2 squares? No. X to the 8th, yes. X to the 10th, yes. X to the 11th, no. Right? And again, you got to get good at recognizing. That'll save you time. All right, you guys are awful quiet. I hope you can ask questions. Let's look at our third example. Uh-oh. Factor out common factors first. Are there any? No. But we checked, right? We check every single time. Uh-oh, 4 things. This isn't even a trinomial. It's got 4. You know what? You got to try 2 parentheses. We're going to try trial and error. You say, but it's got 4 things. I know, but we're going to try it. We're going to try it. So 2 parentheses. All right, so we've never done trial and error with 4 things. Never. But we do know how to do trial and error, right? All right, I'm going to pause. I'm going to give you about a minute. See if you can factor that. Just going to give you a minute, and then I'll show you how if you can't. All right, so I only gave you a minute. Did anybody find it? Anybody? Oh, I'm so discouraged. All right. So let me go through how I taught you to do perfect square or trial and error. Way back, way back. So here's how we learned trial and error. Factor out common factors first, right? Make 2 parentheses. Did we do that? Okay. Did you take the front and get factors of the front to put in the front? Did you do that? Did you take the back and try factors of the back to produce the correct factors in the middle? That's how you do trial and error, right? The fronts are factors of the front. The backs are back factors of the back. And the outers and inners are supposed to give you the middle. Right? Isn't that trial and error? I hope a few of you figured it out in the meantime, because that's all you got to do. Let me see if I can get back there. Come back, wherever you are. Francois, are you there? Where are we at? We past that? Yeah, we're past that. Come back. All right, so here we are. Okay. So do you agree the front can be x cubed times 1, which is silly, or x squared times x? How many did x squared times x? Okay, then you didn't figure it out from there? What does the back have to be? It has to multiply to negative 18, right? All right, so how about positive 2? Doesn't that give me a positive 2x squared? How about negative 9? Doesn't that give me a negative 9x? Doesn't that give me the middle? It's just the fact that our middle has 2 things. But doesn't that give us the middle? Did anybody find it in the meantime? Oh, so sad. 1. All right, so sad. That's the answer. Well, that's the preliminary answer. That's the first part. X squared minus 9 times an x plus 2. Don't you see how that's exactly trial and error? The front is factors of the front. The backs are factors of the back. And when you do the outers and the inners, do you not get the middle? You do. Voila. It worked. Now, are we done? All right, now we look at the front and we see a binomial. And if a binomial is going to factor, it will only factor if it is a difference. If it's a difference of 2 squares. Now, look, do you guys realize, some of you that never want to say anything when I do that, do you realize that you're not helping yourself remember? Do you realize that? Do you understand that? Because didn't you learn from like elementary school that when you write something, when you see something, and when you say something, it helps you to remember? So if you're too cool to talk, then get over that. If you're too shy to talk, and that's probably more than likely the case, get over that. Everybody else is talking at the same time. No one's gonna look at you and think, oh, goofball. All right, so anyhow, get over that. So if this is gonna factor, it's gonna be a difference 2 squares. Is it a difference 2 squares? It is. This first one, 2 parentheses. Plus in the middle of one, minus in the middle of the other. Square root of the front in the front. Square root of the back in the back. And don't forget, you still have the x plus 2, which is not a difference of 2 squares. There's the answer to that one. Cool. All right, this next one we actually did way in the beginning, first assignment. So remember, something that is common can be a binomial or trinomial. So do we see the common x plus 2? All we're doing right now is factoring out common factors first. That's all we're doing. So when I take out the common x plus 2, what do I have left? A y squared minus 4. Do you agree with that? We did that first day of factoring. Is the front binomial a difference of 2 squares? Yes or no? No. Is the back binomial a difference of 2 squares? Yes. So that one we've got to factor. So keep your front. How are we going to do the back? 2 parentheses. Plus in the middle of one, minus in the middle of the other. Square root of the front in the front. Don't look. Think yourself. Square root of the back in the back. Right? Voila! We are there. And that's it. If nothing left is a difference of 2 squares, we completely factored it. Second example is a little bit more off the wall. Now this one gets students because it's tricky. And we're actually going to do some partial grouping. I know this is odd. It's just something to look out when nothing else works. Now, let me pause for a second and help you with analyzing. First off, notice there are 4 things. 4 things, that's unusual, yes? Notice the difference between this one with 4 things and this one with 4 things. What's the difference? That top one has cubes and squares. This one has everything to the first power. That's a major difference. That's a major difference. So we can't do this one by trial and error like we did the other one. It doesn't work because there's no squared or cubed or anything. It's all first power. So that's the difference in those 2 with 4. So in this one, we got to try something different. We're going to do some partial factoring. How about if I take out a common 5x out of the front? Doesn't that leave me a y minus 3? Take a common 5x out of the front. Does everybody see that out of the red parentheses? Just out of the red parentheses. Whoa. How about just a common x? Speak up out there, you Kool-Aid people and you non-Kool-Aid people, right? I can't get a 5 out. I can only get an x out. All right. We still have a 5y minus 3 inside. Does that look better? All right. You guys gotta speak up. You gotta speak up. Okay, and we're gonna do the same thing in the back. Here, let's use red again. In the back again, we're gonna group. And here we can get the 5 out, all right? We can get a 5 out. Do you agree? And what is left in? A 5y minus 3. Do you agree? Are we done? Do you now see the common 5x minus 3 factor? Again, we did this the first day. So can't we factor out the common 5y minus 3? Use your color here. When you do, what's left? Say it if you know it. X plus 5, right? The red part is left. Right? As we took this 5y minus 3 out of both terms, right? We took it out of both. We put a parentheses in its place. And what was left? The x plus the 5. Again, look, that's abstract. I know that's abstract. That's not, something that pops out at you. So again, we're trying to show you the possibilities. All right, let's get to a couple other situations. Look for perfect square trinomials. All right, this one is really abstract. Yes, ma'am. What did I not fill out? Binomial factors. Binomial factors. That would be red if I wasn't going fast. At times you can factor out common binomial factors. All right, the third one. Look for perfect square trinomials when there are 4 terms. All right, so here's a third scenario with 4 terms. Odd already, right? 4 terms is odd. The first time we tried trial and error. The second time, nothing was squared or cubed or anything, so we couldn't try trial and error. We had to go partial. In this third one, you might think, hey, this might work, trial and error. But when you go to try to do it trial and error, there's no way to get the middle terms. There's no way to end up with a 4x plus 4 in the middle. It's impossible. Because you're using x and x and y, and that's going to give you an xy in the middle, and there is no y's in the middle. So you could try trial and error and say, nope, trial and error doesn't work. So then you got to hope it's this last possibility. Look for a perfect square trinomial, and the green is a perfect square trinomial. So this one is really abstract. We're going to factor just the green. Now again, if you knew the pattern, we'd use the pattern. But I'm going to do it like a trinomial. So we're doing just the green. So the front's got to be x and x. And notice the back is plus 2 plus 2. Doesn't that give me the green? X squared plus 4x plus 4. Do you agree? All right, so watch. This is really weird. Let's now put it in proper form. Would you agree quantity x plus 2 quantity squared minus y squared? Do you agree? Technically, what is that that's left? It's technically a binomial, monomial, trinomial. What is it? No, it's actually a binomial. Look, x and 2, if x is 7, it's just a number. It's really technically a binomial. And therefore, this is actually now a difference of 2 squares. It is. Because it is a binomial. The front is a perfect square, there's a minus in the middle, and the back is a perfect square. I go into difference of 2 square mode. 2 parentheses, right? Plus in the middle of one, minus in the middle of the other. Agreed so far? Can anybody tell me what goes in the front of each? Josh? Exactly. What is the square root of x plus 2 squared? Remember, square roots undo squares, right? So you get an x plus 2 in the front. What goes in the back of each? That one's easy, and that's the y, right? Square root of y squared is y. So we get x plus 2 plus y times the quantity x plus 2 minus y. Wow, that's abstract. That's abstract. Now our last example is another form of that, only they factored it already for you. That's easier, right? They already took the trinomial and factored it. Nice, better. So again, you got to recognize this as a difference of two squares. That's what you're recognizing. And therefore you're saying two parentheses, right? It's all in your brain. Plus in the middle of one, minus in the middle of the other. What goes in the front of each? Say it if you know it. X minus 3. What goes in the back of each? Say it if you know it. 1, right? Square root of 1 is 1. Can we simplify this one? Can you add a negative 3 and a positive 1? Yeah. Negative 3 plus 1 is a negative 2. This thing simplifies. Can you add a negative 3 and a negative 1? Yeah, that's a negative 4. We were able to add these up and add these up on this one because they were both numbers. Look at the previous. You had numbers and y's and x's. Do those add? No. Do numbers and numbers add? Yeah. So in this one, you'd finish it up by cleaning it up. And you get all the way down to x minus 2 times quantity x minus 4. That's abstract, but that's the way it goes. Last homework of the chapter. Review tomorrow. Test on Thursday. Review tomorrow. Test on Thursday.